This video is about word problems and applications using areas of figures. So we're going to find the area of the entire figure. So number one, we have two different shapes. We have a parallelogram and we have a triangle. So to find the area, we're going to find the area of each shape and add together. So we're going to do the area of the parallelogram plus the area of the triangle. So remember that area of a parallelogram is base times height. So in this case, our base is 8 and our height is 5. To find the area of a triangle, it's 1/2 base times height. So the base of the triangle is 10 and the height is 5. So when we go to simplify these, we get 5 times 4 is 40. 1/2 times 10 times 5 is 25, and we can add those together. So our total area is 65 feet squared. In number 2, we have 3 shapes. We have the little semicircle, we have the rectangle, and then we have our triangle. So we're going to find the area of all 3 of those and add them together. So we have the area of the semicircle, plus we have the area of the rectangle, plus we have the area of the triangle. So the area of a semicircle, well, remember that a circle is pi r squared, and since it's only half of a circle, we're going to multiply by 1/2. The area of a rectangle is base times height, and the area of a triangle is 1/2 base times height. So if the length of this side is 2, that means that our diameter is 2, so our radius is 1. So we have 1/2 times pi times 1 squared plus the area of the rectangle, 2 times 16, plus in this triangle, if this side is 2, the opposite side is also 2 in the rectangle. So we have 1/2, the base of the triangle is 2, and the height is 5. So when I multiply this out, I get 1/2 pi plus 32 plus 5. I can combine the 32 and the 5, and so if I leave my answer as an exact answer, I have 1/2 pi plus 37 centimeters squared. If I wanted an approximate answer, I can put this all in the calculator to add together. So 1/2 pi plus 37 would get us 38.57 centimeters squared. Now, in the next two problems, we want to find the area of the shaded region, which means the area that's not shaded needs to be subtracted out instead of added. So in number 3, we have two shapes. We have the big circle, and then we have the trapezoid that is white. So the area of the circle is the big area we want to find, and we're going to subtract the area of the trapezoid. So remember that area of a circle is pi r squared, and the area of a trapezoid is 1/2 base 1 plus base 2 times the height. So if 20 is the diameter, then our radius is our 10 and 10. So we have pi 10 squared minus 1/2. We have one base down here, which is 20, and the other base is 12. And we're going to add those together, times our height, which is 8. So for the circle, we get 100 pi minus, and when I multiply out the area of the trapezoid, so 1/2 times 32 times 8 is minus 128 centimeters squared. That would be our exact answer. If we want to approximate, we can put that in the calculator, and our approximate would be 186.16 centimeters squared. So in number 4, we have an 8 by 8 square, and we're going to subtract the area of the circle. Now there's 1, 2, 3, 4 circles that we want to subtract the area. So we're going to do the area of 4 circles. So remember that the area of a square is base times height. And then we have 4 times the area of a circle, which is pi r squared. So the base and the height of the square are 8 and 8, minus 4 times Now we need to find the radius of the circle. So we know that if I draw two diameters through the circle, that because there's two of them, each diameter would be 4, which means the radius is split into 2. So all of these circles have the same radius of 2, so we have pi 2 squared. So here we would get 64 minus 4 times 2 squared, which is 16 pi. If we want exact answers, meters squared. If we want an approximate, we can put that into the calculator. So we would get 64 minus 16 pi, and that is 13.73 meters squared. Now let's look at some word problems. So in number 1, the height of a square is 11 centimeters. If the area of the square is 121 centimeters, what's the length of the base? So remember that the area of a square is equal to base times height. And if you're really quick on it, you should already know that the base length is 11 because squares have the same. If you're not sure, remember the area is equal to 1/2 base times the height of 11. We can divide both sides by 11 and we still get that the base is 11 centimeters. Number 2, the area of a trapezoid is 60 centimeters. If the height of the trapezoid is 6 and one of the bases is 8, what is the length of the other base? Remember that the area of a trapezoid is 1/2 times base 1 plus base 2 times the height. So we have 60 equals 1/2 times the base, which is 6, plus the other base that we'll call x, times the height of 8. Now, the 1/2 and the 8 can multiply together to get us 4. So we have 60 equals 4 times parentheses x plus 6. We can distribute the 4, so 60 equals 24 plus 4x. We can subtract 24 from both sides. 36 equals 4x, and when we divide, x is 9. So our other base then would be 9 centimeters. Number 3, the circumference of a circle is 44 pi meters. What is the area of the circle? So remember that circumference is 2 pi r, and if the circumference is 44 pi, we have that equal to 2 pi r. Because both sides have a pi, that cancels out. We're left with 44 equals 2r. When we divide by 2, r is 22. So now that we know the radius is 2, we can substitute into the area equation, which is pi r squared. So we have pi times 22 squared for the area. And when we square that, we get 484 pi meters squared. Number 4, an isosceles triangle has a legs with a length of 26 and a base of 48. What is the area of the triangle? So in an isosceles triangle, remember that that has two congruent legs, which are going to be 26 and 26. It also has a base that's 48. When we go to draw the height into this triangle, that's going to split the base into two congruent parts. We have 24 and 24. So we can use Pythagorean theorem to find the heights. We have 26 squared equals x squared plus 24 squared. 26 squared is 676 equals x squared plus 576. We can subtract that from both sides. So 100 equals x squared. X is 10. So we now know that the height is 10. So to find the area of the triangle, it's 1/2 base times height. So we get that the area is equal to 1/2, the base is 48, times the height, which is 10, which gets us 240 feet squared. Number 5, the area of a rhombus is 312 millimeters squared. If the length of one diagonal is 24 millimeters, what's the length of the other? So remember that the area of a rhombus is equal to 1/2 diagonal 1 times diagonal 2. So we have 312 is equal to 1/2 times 24 times the other diagonal. We know that half of 24 is 12, so we have 312 equals 12d times diagonal 2. So we can divide both sides by 12, and we get that the second diagonal has a length of 26 millimeters. So application word problems. Number 6, Jack has a fenced-in rectangular garden that he needs to seed. Jack already bought and installed 192 feet of fencing to go around his garden. He remembers that the garden is 12 feet long, but can't remember how wide it is. Jack plans on buying packets of seed that cover 8 feet of ground and cost $1.75 each. So how much will Jack have to spend on the seeds? So first, we need to figure out what the dimensions of this rectangular garden is. We know that one of the sides is 12, and we're trying to figure out what the other side is. So remember that they have congruent sets of sides, so really two sides are 12, and that the perimeter is adding all the sides together. So we have 192 equals 12 plus x plus 12 plus x. So we get 192 equals 2x plus 24. We can subtract 24 from both sides, and we get 168 equals 2x. We can divide both sides by 2, and we get 84. So that means that the other dimension of our rectangle is 84 and 84. So to find the area then, we know that the area is base times height. So we have 84 times 12, which means that the area is 1,008 feet squared. Now we want to figure out how many bags of seeds he needs. So we know that for the bags of seeds, that it covers 8 feet each. So we're going to do 1,008 divided by 8 feet squared that it covers per bag. And we get 126 bags that we would need to seed the garden. We also know how much they cost so we can figure out the total cost. So if we need 126 bags, we can multiply by the cost of $1.75 each. And we get $220.50. Number 7, Jack already seeded his grandpa's square garden, and now he needs to put a fence around it. Jack does not remember the dimensions of the square garden, though. He remembers he purchased 5 packs of seeds. If each seed pack covers 20 feet squared, how much fence did he buy? So we can do the pack of seeds times how much they cover. So we know that the garden is 100 feet squared. So remember that the area of a square is equal to base times height, but in a square, they're equal. So we're going to call that x squared equals 100 because we're looking for the base and the height. So when we take the square root, we know that x is 10. So each side of the square has a length of 10. So if the perimeter is 4 times 10, he's going to need 40 feet of fencing. Our last question, Jack also needs to brick the semicircle patio at his parents' house. The diameter of the patio is 18 feet. If the bricks cost $12 per 7 feet squared, how much will the bricks cost? So in a semicircle, remember that the area of a circle is pi r squared, but we only want half of that circle. So we're going to do 1/2 times pi 18 squared. So we're going to square 18 first and then multiply that with a half. And we get 162 pi feet squared. So to figure out how many bricks he needs, what we're first going to do is we're going to divide the area by the 7 feet to see how many bricks he needs. So we can put 162 with the pi in, divided by 7 in the calculator, and we get 72.71. Now, they're not going to let us buy partial bricks, which means we're going to need to buy 73 total bricks. So if we have to buy 73 total bricks, we are going to multiply the 73 times the $12, and we get $886.